Good morning, Cappuccino. Here is our warm-up for Wednesday, May 6th. There's a flu epidemic in Cozy Town. Oh man, why are there so many epidemics? On the first day, 2 people have the flu. On the second day, 10 people have the flu. And on the third day, 50 people have the flu. Sound familiar? Show that the number of people with the flu forms the first 3 terms in a geometric sequence. Calculate how many people have the flu after 1 week. Okay, on day 7, that would be day 7. Use your model to calculate how many people have the flu after 1 year. And then, this is the most important part. Comment on the reasonableness of your answer. So, I want you to bring to bear what we have seen in the COVID-19 epidemic. What have people been talking about on the news? Bring some current events into this when you talk about the reasonableness of your answer. Okay, so figure out how many people would have the flu after 1 year, and comment on whether you think this is likely to happen and why or why not. Why or why not? Okay, so I want you to bring some current events into this. All right, there's my dogs. They don't want you to bring current events into it. All right, back to yesterday's warm-up. For those of you who already got it right, you can turn off the video. I'm not going to say it anymore. This one, I tell you it's an arithmetic sequence. So that means I'm adding the same amount each time. So each time I go from one term to the next, which is some pretty big terms, I'm adding the same amount. So I know I can write some equations. I know that 2 plus d is equal to a minus b. I also know that a minus b plus d is equal to 2a plus b plus 7. And I know that 2a plus b plus 7 plus d is equal to a minus 3b. Wow, I'm running out of room already. Okay, I'll write that one down in a minute. So then what I can do is I can rearrange these so that I can use some substitution. So I notice these both have a d. It'd be really easy to get the d by itself. So I'm going to minus 2 from both sides, and I get d is equal to a minus b minus 2. And same thing here. I'm going to minus the a and plus the d. So if I minus a from both sides, 2a minus 1a is 1a. Negative b, to get rid of that, I'm going to add b. So add b over here. B plus b is 2b. And I still have my plus 7. Okay, now I can set these equal to each other because d is the same as d. So I can say, all right, a minus b minus 2, using a little substitution here, a plus 2b plus 7. Okay, since they both of these expressions equal d, I can use substitution to set them equal to each other. Now I'm going to try and rearrange this. If I minus a from here, minus a from both sides, oh, the a's disappear. Isn't that convenient? So I'm left with negative b minus 2 is equal to 2b plus 7, and now I can solve this for b. So add b to both sides, I'm going to get 3b equals, and minus 7 from both sides, I get negative 9. Divide both sides by 3, I get b is equal to negative 3. Okay, now I can substitute that back into my original equation, and no, I can't. I have to write another equation. That one's not going to help me because the a's cancel out. Okay, so now I need to use the other equation. I'm going to set up this one where I have 2a plus b plus 7 plus d is equal to a minus 3b. And I'm going to solve this one for d. So I'm going to have d equals, I'm going to minus 2a. If I minus 2a from both sides, I get negative 1a. I'm going to minus b. If I minus b from both sides, I get negative 4b. And I'm going to minus 7 from both sides, so there's no constant over here, so it just becomes a minus 7. Okay, so now I can also set this one equal to either one of these, whichever one I feel like. Let's see, when I did this before, I made it equal to, did I do? -7 and the +7. I use this one. Okay, so I can set these two equal to each other now. So A plus 2B plus 7. Since these are both equal to D, I can set them equal to each other. It's equal to -1A minus 4B minus 7. I just didn't want to go back and use this one again because I know these A's are going to cancel out, so I can't solve for A on that one. Okay, so now I can substitute in my -3 for the B. So wherever my B's are, I can stick in my -3, and then I'll be able to solve for A. So 2 times -3 plus 7 is equal to -1A minus 4 times -3 minus 7. So I get A minus 6 plus 7 is equal to -A plus 12 minus 7. So I get A plus 1 is equal to -A plus 5. Add A to both sides. I get 2A minus 1 from both sides is equal to 4. So A is equal to 2. All right, so I've solved for A and B, so now I just need to go and plug those back in to the original sequence. So I'm going to have this one right here. A is 2 minus -3. That gives me 5. So the second number in the sequence is going to be 5. And so this one should be 8, right? Because D would be 3. 2 plus 3 is 5. So this one should better be 8. So this is kind of a way of checking to make sure I didn't make any mistakes. So I'm going to have 2 times 2 plus -3 plus 7. So 4 minus 3 is 1. 1 plus 7 is 8. Yep. Everything's working out fabulously. All right. A is 2 minus 3 times -3. Negative times negative is positive. 9, 10, 11. Is that 3 more than 8? 8, 9, 10, 11. Yep. So my sequence is 2, 5, 8, and 11. That is the sequence, the 4 terms of the arithmetic sequence. Ta-da! Okay, stay tuned. There will be notes today. We are going to then use the notes to help us do a math space assignment. So that'll be coming along a little later. And there are office hours today at 10:30. And there will be office hours again on Friday at 10:20. So sign up if you want to ask a question or just show up. And I will. I already sent out the invitation for today, and I'll send out the invitation for Friday. I'll do that tomorrow. All right. See ya. Bye-bye.